In this test, we are going to check the solubility properties of 4 different compounds of the class that is called the alcohols. And first, we're going to test their solubility in water, a polar solvent. Right now, I have 4 test tubes here, each of which has about a milliliter of water in it. I didn't measure, I just put 20 drops in there, and that's approximate. What I'm going to do now is I'm going to add 20 drops of each alcohol to each tube. So, for example, tube number 1 is going to get ethanol. And what I'm going to do, again, be careful to make sure that when you open the cap, right, you don't put it down on the bench. You hold it between your little finger and the palm of your hand. Use the dropper bottle, and we're going to drop 20 drops of this in here, about a milliliter. So more or less that. Okay, so I'm going to put the cap back on here. And now I'm going to do the same with all the other ones. Okay. Okay, so I've added 20 drops of each of the alcohols to each tube. Remember, tube number 1 had ethanol. Let's see what the result is with that. As you can see, when I added the ethanol, there's a single phase of liquid all throughout. The second test tube received the compound, the alcohol 2-propanol, sometimes called isopropyl alcohol. It's what we call rubbing alcohol. And again, as you can see, there is complete mixing of the two. Tube number 3 received a compound called 2-methyl 2-propanol. You can see in your handout what the formula of that is, what the structure is. And as you can see, in this case, we had a little bit, maybe a little bit of a layer on top, right? A little bit of a layer on top. It's kind of hard to see right now. I'm trying to angle it so you can see just at the very, very top, there's a little bit of a layer. And then for tube number 4, we added something called 1-pentanol. And in this case, you can see that there are 2 distinct layers of liquid in there. So remember that our idea is that we call something that completely dissolves, right? Something that is completely soluble, one that forms just like a single layer. If you can see the separation between the layers, like in this case, we say it's insoluble or immiscible. And if we see, like we said here, I'm sorry that it's kind of hard to tell on the camera, there's a little tiny little layer on the top. We would say that is a slightly soluble or partially miscible solution mixture. So essentially, the task that we have at hand is, now that we have seen this, let's say now that instead of using water as our solvent, we test a nonpolar solvent such as hexane. So we're going to do that next. Okay, you can see that I transferred my equipment to the fume hood. The reason is we are starting to work with a lot of volatile compounds that, the smells might bother people. So to be careful, we're going to do this in the fume hood. And what I've done now is, again, I have my test tubes 1, 2, 3, and 4 with about a milliliter of solvent. But in this case, the solvent is called hexane. You can see the formula there, C6H14. And if you want to look up its structure, you can do that. The point is that it is a nonpolar solvent. So what we're going to do now is going to test the solubility of all of these guys that we did before. So I'm going to start again with tube number 1, which is ethanol. Once more, I'm going to loosen the cap, hold it right between my little finger and my palm of my hand. I'm going to grab some of this and I'm going to put 20 drops of it in test tube number 1. Okay, and just like I did in the previous experiment, now I'm going to repeat that with test tubes 2, 3, 4. And again, I'm going to be adding different types of alcohols in here. All right, let's see what happens. Okay, I've added 20 drops of these different alcohols. Again, test tube number 2 was the 2-propanol. Test tube number 1, I already showed you, was the ethanol. Let's see what that looks like. So here's test tube number 1. We see a single layer. We can even stir it a little bit, and you can see that you can see the little layer. Let me see if I can put it in a spot where you can see the little layer at the bottom. I'm going to mix it a little more, see if I can get them to mix. And in effect, what you can see is, I hope you can tell that there's a layer in the top and a layer in the bottom. This is the number 2 tube, which was propanol. I'm going to mix it a little bit. You can see where there's no layers. It's completely uniform or homogeneous. Here's test tube number 3, which was the compound 2-methyl-2-propanol. And you can see that one is, again, completely miscible. And then test tube number 4 was the compound 1-pentanol. And let's see that one, what it looks like. Again, it's completely miscible. There's no layers. So in this case, test tubes 2, 3, and 4 showed complete miscibility, whereas test tube number 1 retained that layer of those 2 separate layers. And again, you could call it either immiscible or partially miscible, either one of them. All right. Like I said, it's very difficult here. I don't have really the proper tools for display here. I wish I did. Let me see if using my hand. There you go. So you can see the 2 layers in there. See them there, right? There's a layer in the bottom, right on the curve of the tube, and then there's a layer on top. All right. So those are the results. Now, your task is the following. Now that you have seen how each one of these alcohols behaves when you mix it with a polar solvent like water versus a non-polar solvent like hexane, what you want to do is go back and look at the structures of these 4 alcohol compounds and try to determine what types of intermolecular forces they're capable of, and use that to explain the properties of solubility or miscibility that each one of these alcohols has with water versus hexane. So for example, you would expect that a compound that is polar would not dissolve properly, would not be miscible with a non-polar solvent like hexane. But explain why. Why are the intermolecular attraction forces different? All right. So that's the demonstration, that's the experiment. You can go ahead and fill out the data and answer the questions in your handout.